Okay, so take a second to read through the warm-up, pause the video, and then try it out on your own. So I'm going to assume that you tried out this problem, and let's think about it. So if the Minnesota Vikings are known for winning 77% of their football games, what is the probability that they win at least 3 of the next 15 games? So we got to start by figuring out our N. So our N in this case, we know there's 15 games. What's our probability of success? Well, they've won 77% of their games, so 0.77. And then what's their R? Well, we want to win at least 3. So if you think back to your notes, when it says at least 3, which one do we need to use? Well, we need to use the binom CDF. So then we have binom CDF. And in parentheses, we have our N, so 15, comma, probability of success, 0.77, comma, at least 3 to 15. So what do we type in? We type in 2. So obviously with this binom CDF, we need to make sure that we are doing the 1 minus the binom CDF, because again, when we're doing at least, that's what we have to do this. And again, how do we get 2? Because if we're saying that there is at least 3, well, that means we have to do 3 minus 1, and that's how we get 2 here. When you go ahead and you plug that in your calculator, you should get 0.9999. So next, what's the probability that they lose exactly 4 of their next games? So this stuff stays the same here, N and P, but this time our R is equal to 4. Okay. Now this being said, notice that lose is bolded here. Well, remember, if you think about it, P is your probability of success. So if we're successful 77% of the time, how much are we not successful for? Or in other words, how do we find Q? We need to do 1 minus 77, and 1 minus 77 is 0.23. So now we can go ahead and plug this in. When it's exactly, we use our binom PDF. So we have binom PDF, and in parentheses we have 15 trials. This time our probability is the 0.23, and then for a total of 4 times. And when you do this in your calculator, you should get 0.0108. Alright, let's take a look at the next question. A biologist is studying a new hybrid tomato. It is known that the seeds of the hybrid tomato have a 70% chance of germinating. What is the probability that at most 2 out of the 5 seeds do not germinate? So again, we want to do our N, P, Q, or R. Obviously, again, if we're doing this N, P, Q, or R, we have checked for bins, so I'm hoping you can also take a second and check for bins to make sure that we can do this. So it tells us 5 total seeds are participating in this. Our probability of success is 0.7, therefore our probability we fail is 0.3. And then it wants at most 2 out of the 5 seeds. So obviously we can have 0 seeds, 1 seed, or 2 seeds, but at most is 2. So when we have at most, we now use binom CDF, and then in parentheses we have 5 for N, our probability of success is 0.7, and then our R we plug in 2. Oh my goodness gracious, I'm so sorry. It says do not germinate. I was doing germination. I apologize. Do not germinate. I even bolded it and I missed it. 0.3. Do not germinate, so that means we're failing. So 5, 0.3, 2. And when we put this in, we get 0.837. So if you haven't already gotten out this paper, please make sure you pull it out, because we have the last thing to talk about down here. We want to talk about our mean and our standard deviation of a binomial distribution. So if we take a look here, our mean, so again this is a mu, so we're saying mu is equal to n, which is your number of trials, times p, your probability of success. our standard deviation, sigma, again for a population, is equal to the square root of n times p times 1 minus p. And if you remember from yesterday, we wrote up earlier that the probability of failure is also known as 1 minus p. So in reality, this is really the square root of n times p times q. So that's our standard deviation if you want to add that to your note sheet. So once you have that added, let's go ahead and try an example. If you would like to write this down on the back of the sheet so you have an example for you, that might be helpful. So here we go. Isabel Brigg Myers was a pioneer in the study of personality types. Her work has been used successfully in counseling, educational, and industrial settings. Using her type indicator test, it has been found that about 65% of society are extroverts. There are about 1,300 students in our school. What is the expected number, another way for saying the mean, of students who are extroverts? What is the standard deviation for this data? Okay, so then we need a few things in here. We need to know what our n is, we need to know what p is, and q. So n, well, how many people are in the school? There's about 1,300. P, what is our probability of success? Or in this case, we're looking for how many are extroverts, that's 0.65. So therefore, if yes, that's 0.65, then if no, it's 0.35. So when we want the expected value, we just do 1,300 times 0.65. That's our mean. And when you do that, put in your calculator, you should get 845. But now obviously, what does 845 mean? Is that Doritos, tomatoes, potatoes? No. It is 845 students, so make sure you put the label in. Standard deviation, we now take the square root. We have our n, 1,300, times our p, 0.65, times our q, 0.35. Pretty straightforward once you get this information. You plug it all in your calculator. I would suggest multiplying all these first, so then you can take the square root after that. And when you do, it is 17.2. Okay, so the expected number of students who are extroverts is 845, and that fluctuates within plus or minus 17 students. Obviously, we want to round down a little bit because we don't have 0.2 for students. So what I'd like you to do after this is you should be getting the binomial problem set and working through that. She will have the answer key if you would like to check your answers at the end of it. If you have any more questions, you can bring them on Monday. Please, please, please make sure you bring everything for your experiment on Monday as well.